Okay, so this lesson is about how to use the oscilloscope using multisim, and what we'll do is we just put in a function generator. So function generators are on this side right here, most right hand side. See how I'm hovering over, and you see multimeter next to that is function generator. So that's the function generator, and I need to put a load of some sort. So well, I'll put a ground first, a couple of grounds. We'll need about 3, so put some there, get going. And then I'm going to put just a simple resistor in there. It doesn't matter, all you're trying to do is to put a load to that circuit. So the function generator here is just like the DC power supply that we use. So just to make it neater, I will just turn this around like that, and then I'll put the ground. Common goes to the ground, and I'll change the color of that to green. We'll go ahead and save this also. Just call it scope. Okay, and then I will bring the power supply here. Let's see if I can get rid of all these words in there. So you don't need all that. Okay, won't let me do that. Well, I guess it won't. I'm going to turn this resistor just a little bit. There is a way to get rid of this. Just move there and we move the screen over. There we go. More than one way to get there. Okay. And then, so that's my power supply. Okay. So this is my power supply. It's like the DC power supply. Only difference is that this is an AC power supply. And so the last time what we did was we pulled in an oscilloscope. Let's see if I can see that. Just this one here. So this, I mean, it does a job, but it's a virtual oscilloscope. You'll never see one of these things in real life. So let's go to a real oscilloscope. So we need to go down here. So there's different kinds of oscilloscopes. So Elegant, let's do Tektronix. That's a good sounding name, Tektronix. Okay, and so on the Tektronix it has 4 channels. So you see, I just double clicked on it, channel 1, channel 2, channel 3, channel 4, like that. So remember, with that virtual oscilloscope there are only 2. This one has 4. So you can't connect anything to these terminals here like this. By the way, these are called the BNC jacks. So this is like a cable TV jack, you know. Well, not really cable TV, because cable TV is a screw terminal. This is like a clip terminal here. So this is a BNC jack. So there's like 2 pins here, and it'll hold the lead in place. So the ground is this G, and we are only going to use channel 1, so we just connect channel 1 to this power source. Pull this down a little bit so that I have some space. Okay. And so that will be my input to the oscilloscope. Right, so this negative terminal here, by the way, is a negative power supply. This is a positive power supply. Obviously, now it just produces the opposite waveform. Okay. Okay, so I'll pull this. I don't need to see anything on here now. I'll just cover this up so that I have some space. Just do it just like that, in fact. And I'll turn the power on, and nothing happens. And the reason why, the reason why I don't get a waveform here is because I need to turn the power supply, to turn the oscilloscope on. Okay, but before I do that, let me just go and see what this function generator is set at. So it's set at 1 hertz. 1 hertz is like a very difficult. It's really not. It is a sine wave, but it's very difficult to see that. I just turned it to 1 kilohertz, and let me now turn the power on, and you see the waveform there. Obviously, enough, you can't read that because they're like overlapping. So with this oscilloscope, the easiest way to make a waveform that you can see is do auto set, which is right here, and then you get a single waveform. Now, obviously, now this is not a whole lot better. So what I have to do is kind of spread this out a little bit, and I do that with this button right here, the volts per division button. Well, maybe not. Take that back. You change it with time, which is this one here. Volts per division. It will do it in the vertical axis, the y-axis. Actually, what I want to do is to change the x-axis, right? So that's this knob right here. So I'll turn that a little bit. It's obviously not this virtual oscilloscope, so it works slightly different to the real thing, because the actual real oscilloscope, when you do auto set, you'll get a nice waveform. This one gets slightly different. Go ahead and turn that power off and just kind of move this waveform a little bit so that I can see it better. So that's one complete cycle. So let me see if I can stop that. So I stopped it right here, okay? And let me see if I can move this around a little bit. You see how I'm moving it back and forth? So what I need to know is what is the voltage and the frequency here. So remember the frequency is, or the period in this case, is the length of this cycle. So if I start from right here, I'll go all the way to the top, go to the bottom, come back here. So that's one complete cycle. So this thing doesn't have those cursors like what we saw on Multisim oscilloscope. This is a real oscilloscope. How you can do that is just, you see up here it says measure. If you click that, you get the values here. So obvious enough, now it says none, none, none. That's because none of these things have been set. So we'll do, let's do peak to peak volt. Well, let's see what the first one. So it says source channel 1. That's this source channel 1. If you wanted to channel 2 like this, you can do it like that. Also, it depends on where you connect it. The waveform colors will change. So you can have like a yellow, blue, pinkish, and green color. So let's do, let's see frequency, the first one that comes up. And see how it says what the frequency is down here. So if I go back to measure, it says channel 1, frequency 1 kilohertz. So that's actually what the frequency is right here, right? So I want to know a couple of other things. I want to know what is the period. I'm too lazy to take the inverse. There we go. That's 1 millisecond. I want to know what is the peak-to-peak voltage. I'm too lazy to count these squares. So I'm going to just do this one here and do peak-to-peak. There we go. Peak-to-peak voltage. So peak-to-peak voltage is 19.920. So that's correct, right? Because you see how it says right here, the peak voltage. So let's see what else we can find out. Frequency, period, mean, it's like average, peak to peak. So we want to know what is RMS. I'm too lazy to divide this number by 2 and multiply it by 0.707. There we go. Now I know what the RMS voltage is, 7.0. And that's correct, right? If the peak voltage is 10 volts, you multiply that by 0.7, you get this number. Okay, so that shows how to measure frequency and period using the real oscilloscope. So let's go to another frequency. Let's make this 1 megahertz. Then power back on, it's on. And I think I stopped it, right? So let me run it again. So now obviously you can't see this, right? So I'll do auto set and see if it'll give me a waveform. That was not any better. Okay. Okay. So what I need to do is just kind of change this. See how I'm changing this now. There we go. And now I see a waveform. And let's see if I can make it a little bit better. There we go. And this is not very tall. I want to see like if there are any like glitches here. I mean, that's one of the reasons why we use oscilloscope, is to see get a clean waveform. Obviously, if you're getting an absolutely pure waveform here, that's because it's a simulation. So that's a little bit better, right? I can see a lot more of this waveform in that. I don't know if I can make it any better. So with the actual oscilloscope, you actually can make it look much better. But we can also go back to that, the measure, and see, oh, well, we lucked out, everything is right there. So the frequency is 1 megahertz, which is this number right here. The period is 1 microsecond, peak to peak voltage. Let me see if I can change that peak to peak voltage from 10 to, I'll make it 20. Okay. So let's see if I can get a little bit more of this. And let me do measure again. And now you see the voltages have changed. See, it's 40 volts peak to peak. And that's correct, right? Because this is 20 volts peak, so this must be 40 volts. And you also get RMS voltage and things like that. So if you want to know what your wall socket frequency is, well, let me not do that. I'll let you do that. So that's your assignment. What would you get on the oscilloscope? The frequency, period, peak to peak, RMS of your wall socket. So that is your assignment, to do that, to make a snip of it and upload it to Canvas. We call it wall socket measurement. Just as a point of reference, if you're actually going to do that, if you're going to measure voltage and frequency of the wall socket, you do need to be quite careful how you do it, because one can get a serious jolt out of this. Right? There we go.